All right, welcome everyone. When we talk about AI, our minds usually jump straight to the digital world, right? Things like chatbots or what Netflix thinks you should watch next. But today, we're going to switch gears a little bit. We're going to look at how AI is getting its hands dirty, so to speak, in the physical world. We'll be diving deep into something called AI-driven predictive maintenance, which is basically how machines are learning to predict their own future.
So let me just start with this question. What if a machine could actually tell you it was about to break down? I'm not talking about just a simple warning light. I mean, imagine a giant wind turbine or a jet engine sending you a message saying, hey, in about 72 hours, my main bearing is going to fail. This isn't science fiction anymore. This is the real-world result of using AI, and it's at the very heart of what we call predictive maintenance.
Okay, so to really get why this AI approach is such a game changer, we first have to look at how things used to be done. We need to understand the old way and why, frankly, it was broken.
For a long time, there were really only two ways to handle machine maintenance. The first one was, well, you just waited for something to break. That's called reactive maintenance. A machine fails, everything grinds to a halt, and you scramble to fix it. Total chaos, right? The other way was to be a little more organized and do scheduled maintenance. So, say, every 6 months, you replace a certain part, whether it needs it or not. The problem is, you might be throwing away a perfectly good part, which is wasteful, or worse, the part fails the week before its scheduled replacement. You're either wasting money or you're still facing those unexpected breakdowns.
So you can see the difference here. It's really night and day. The traditional way is all about reacting. It's based on fixed schedules or, even worse, just waiting for disaster to strike. That means higher costs and a ton of unplanned stressful downtime. But predictive maintenance? That's proactive. It's smart. It's driven by actual data from the machine itself. This means you're optimizing your costs and making your whole operation way more reliable. We're moving from just managing failure to actually preventing it. And that's the huge shift.
And what makes this incredibly possible? You guessed it. It's artificial intelligence. AI is the engine driving this entire change, taking us from being reactive to being truly predictive. So let's break down the official definition. It's an AI-powered strategy that anticipates failures before they happen. The key words here are anticipates and only when necessary. We're not just guessing based on old averages anymore. The goal is to do the right maintenance on the right part at the exact right time. It's all about precision, which saves time, money, and a lot of headaches.
And that really is the whole goal here. We're shifting from reacting to failure to anticipating needs. Think about it. It's about moving from a state of constant uncertainty to one of control. Instead of a machine failure being a surprise emergency, it becomes a predictable, manageable event on the calendar.
All right, so the big question is, how does this actually work? How can a machine listen to itself and predict its own future? Let's get into the nitty-gritty of the process.
Well, it all starts with data. Lots and lots of data. Modern machines are absolutely packed with sensors, and these sensors are constantly streaming information. We're talking about vibration analysis, temperature readings, even acoustic signals, like the sounds the machine is making. This flood of real-time data gives the AI its eyes and ears, allowing it to have a complete, second-by-second picture of the machine's health. And that data feeds into a pretty straightforward four-step process. First, you collect all that sensor data. Second, AI algorithms sift through all of it, looking for patterns, tiny changes that a human could never hope to spot. Third, based on those patterns, the AI model predicts a potential failure and can even estimate how much useful life the part has left. And finally, step 4, you get an alert, and you can act proactively. You schedule the repair before anything ever breaks. Now, if we want to get even more advanced, we can talk about a really cool concept called the digital twin. You can think of it like a machine's own virtual health monitor, or maybe even its own digital doctor.
So, a digital twin is exactly what it sounds like, a perfect virtual replica of a real, physical machine. This digital copy is constantly updated with real-time data from its physical counterpart. And the really powerful thing here is simulation. Engineers can run stress tests on the digital twin. They can push it to its limits, see what would happen under different conditions, all without ever putting the real, multi-million-dollar piece of equipment at risk. It's like a perfect sandbox for predicting the future.
Okay, this technology is obviously really cool, but what's the actual payoff? Why does this matter so much in the real world? Let's talk about the bottom line. The benefits are huge, and they're things you can actually measure. First off, you get a massive reduction in unplanned downtime, which saves companies an absolute fortune.
You also get lower maintenance costs because you're not fixing things that aren't broken, using your expensive assets more efficiently, and the whole operation just becomes so much more reliable and predictable.
And hey, don't just take my word for it. Industry experts are all over this. Back in 2019, the writer Bernard Marr called it one of the most valuable applications of AI in operations, and he's spot on. This is a perfect example of AI delivering real, measurable economic value today.
And this isn't just a theory. It's happening right now. You've got industrial giants like Siemens using predictive maintenance all over the world, in everything from their high-tech factories to how they manage smart energy grids. It's all about driving efficiency and resilience.
And it's not just for manufacturing. Take a look at the energy sector. A company like Shell uses this technology on incredibly high-stakes equipment like offshore oil rigs. Predicting a pump failure there isn't just about saving money. It's about preventing a potential disaster and, most importantly, keeping people safe.
So, when you step back and look at the big picture, what we have is a system where AI is basically learning to translate the language of machines, turning raw sensor data into clear predictions about the physical world. It's this powerful link between the digital and the real, and that leaves us with a really big question to think about. If AI can predict when a complex piece of machinery like a jet engine is going to fail, what else can it predict? What about something as complex as a global supply chain, or financial markets, or even ecological systems? The foundational principles we've talked about today are just the beginning.